Hi, this is Ajay Anand and welcome to science classes from excelup.com. In this lesson, we will learn about organic compounds. You will learn about chemical properties of organic compounds. Then you will learn about the chemical properties of two important organic compounds, which are ethanol and ethanoic acid. And you will learn about the cleansing action of soap. Carbon undergoes combustion. So let us start with combustion reaction. So when carbon undergoes combustion, it produces carbon dioxide, heat and light. The equation is C plus O2 is equal to CO2. So organic compounds, because they have carbon, so when they undergo combustion, they also form carbon dioxide and they produce heat and light. So this example is of combustion of methane. CH4 plus 2O2 is equal to CO2 plus 2H2O plus heat and light. This is methyl alcohol. CH3 CH2OH plus O2 is equal to CO2 plus H2O plus heat and light. Oxidation reaction. Combustion is also an oxidation, but this reaction is somewhat different because here oxygen is involved in oxidation, but in this reaction oxidizing agents other than oxygen are involved. So when ethanol is heated in presence of alkaline potassium permanganate or acidified potassium dichromate, it gives ethanoic acid. The equation is CH3 CH2OH is equal to CH3 COOH. Addition reaction. The unsaturated hydrocarbon, they have a tendency to add extra hydrogen atom if proper conditions are given, so that they can become saturated hydrocarbon. So in this example, ethene, that is C2H4, is heated with hydrogen in the presence of nickel catalyst, then it gives C2H6. So ethene becomes ethane. In this case, when ethene reacts with chlorine, the double atom bond disappears, and this product of this reaction, it becomes ethyl dichloride. Substitution reaction. This reaction happens in case of saturated hydrocarbon. So in this reaction, methane is reacting with chlorine in presence of sunlight. So what happens? Chlorine substitutes hydrogen atom to give methyl chloride plus HCl, hydrochloric acid. This reaction can go on and on. So it will once again produce CH2Cl2, then it will produce CHCl3, and finally it will produce CCl4, that is carbon tetrachloride. Another example is of ethane. C2H6 plus Cl2 is equal to C2H5Cl plus HCl. Let us now move on to two important organic compounds. First is ethanol. The molecular formula is C2H5OH. The common name is ethyl alcohol. It is a highly volatile substance because it has low melting and boiling point, and it is highly inflammatory also. The reaction with sodium. So here it behaves the way a base behaves because of OH ion over here, OH radical over here, or functional group over here. So when ethanol reacts with sodium, it produces sodium ethanoate plus hydrogen gas. The equation is 2CH3CH2OH plus 2Na is equal to 2CH3CH2ONa plus H2. Oxidation reaction. I talked about it earlier also, that when ethanol is heated in presence of alkaline potassium permanganate or acidified potassium dichromate, it gives ethanoic acid. The equation is CH3CH2OH is equal to CH3COOH. Dehydration. When ethanol is heated along with concentrated sulfuric acid, it gives ethene. The equation is CH3CH2OH is equal to CH2CH2 plus H2O. So here what happens, it is losing a molecule of water because of this reaction, and that is why this is called dehydration reaction. The usage of ethanol are in making medicine, tincture of iodine, cough syrup, and in making alcoholic drinks. Ethanoic acid. The molecular formula is CH3COOH and its common name is acetic acid. Acetic acid freezes during winter, so this is also called glacial acetic acid. The acetic acid reacts with a base the way any inorganic acid would react, so it ends up making a salt and water. So the equation is CH3COOH plus NaOH is equal to CH3COONa, that is sodium acetate plus H2O. Esterification reaction. When ethanoic acid is mixed with ethanol and both are heated, it produces ethyl acetate. In fact, when any carboxylic acid is heated along with an alcohol, so both of them, they produce a sweet smelling substance that is called ester. Esters are sweet smelling substance and they are used as food additive. Now hydrolysis of ester takes place when ester is reacted with sodium hydroxide. So and once it reacts with sodium hydroxide, it produces the parent alcohol. So in this case, the ethyl acetate, when it reacts with sodium hydroxide, it produces ethyl alcohol or ethanol plus a sodium salt of the subsequent related acid. So the equation is CH3COOC2H5 plus NaOH is equal to CH3COONa plus C2H5OH. Now this reaction is very important because this is also called saponification reaction. Let us understand why. The ester of higher fatty acids gives sodium salt of higher fatty acids. So this is a sodium salt of an acid. Such salts, they are called soaps. So this reaction is utilized to produce soap, and that is why this reaction is called saponification reaction. Let us move on to reaction with carbonates and bicarbonates. So you can recall in the chapter on acid and bases that when an acid reacts with a carbonate or bicarbonate, it produces a salt, carbon dioxide and water. The same thing happens here also in case of ethanoic acid. So when ethanoic acid reacts with sodium carbonate, it produces sodium ethanoate, carbon dioxide and water. Same thing happens in case of bicarbonate also. The equation is with carbonate 2CH3COOH plus Na2CO3 is equal to 2CH3COONa, that is sodium acetate, plus CO2 plus H2O. In case of bicarbonate, it is CH3COOH plus NaHCO3 is equal to CH3COONa plus CO2 plus H2O. Soaps and detergents. Soaps are sodium salts of long fatty acids, and detergents are sodium salts of benzene sulfonic acid or of long chain alkyl hydrogen sulfate. Soaps are very good when they are used along with soft water, but they fail to work in hard water. So we need detergents because detergents can work equally well in both soft water and hard water. A soap molecule has two ends. There is a head and there is a tail. The head is hydrophilic in nature, so it has affinity with water, and the tail is hydrophobic in nature. So what happens? Grease contains oil or fat. So when we apply soap on cloth, what happens? The soap molecules, they get attached with grease particles. The hydrophobic end, it attaches to the grease particle. Okay, and gradually many molecules, they attach to the grease particle, forming a globe-like structure surrounding the grease particle. This globe-like structure with grease particle at the center is called a micelle. So here hydrophilic ends, they are at the periphery of the sphere with sodium ion over here, and hydrophobic ends, they are towards the center. So now when cloth mixed with soap is agitated by any means, say in a washing machine, or you beat it with a heavy wooden stick, what happens? The grease particles, they get washed away along with water, and that is how soap helps us in cleaning our clothes. To sum up, I talked about some important chemical properties of organic compounds. I talked about two important organic compounds, ethanol and ethanoic acid, and then I talked about the cleansing action of soap. That's all for this lesson. Thank you.